So here we are, inclined plane, connected particles and a pulley. Let's see how we get on with this one. So there's our question and the diagram that we've been given with the force P at 15 degrees to the plane. So the first thing we're going to do is put the forces on the force diagram. We've got the force, which is the weight of particle A, the normal reaction from the surface on A, the tension in the string, and the weight of particle B. mg, we don't know what the mass is, so I've just called the mass m for the time being. So for part A, we're trying to calculate the mass of particle B. The system is in equilibrium. There's no friction because the plane is smooth. And so what I'm going to do is resolve parallel to the plane for particle A. And when I do that, I've got three forces that have got a component parallel to the plane. We've got this T here. We've got a component of this force here parallel to the plane, and we've got a component of this force here parallel to the plane. So we've got T in the upward direction, because that's the direction I'm choosing to take as positive. Minus 10 cos 15 is the component of P parallel to the plane, minus 3g times the sine of 20, and that equals 0 because there's no acceleration. So that gives me a value for T of 19.7 newtons. Now I can look at particle B and resolve in that direction for particle B. So I get mg minus T equals 0. So mg minus T is the resultant force in this direction, and that equals 0 because there's no acceleration. So from that, m is 2.01 kilograms. It's T divided by 9.8. So what about part B? Now for part B, the force P is removed. So this force here is now removed. And we're looking at particle A now, resolving up the plane. We've got T minus 3g sine 20. So we've got the T up the plane and then 3g sine 20 down the plane. And that's the resultant force equals the mass times the acceleration. So we can write down an expression for T, the tension in the string. Then we can resolve for particle B downwards again, and this time it's mg minus T equals not 0 this time, but m times a, the acceleration. We know that the mass is 2.01, so I've got another expression for the tension here, 2.01g minus 2.01a. So I've got simultaneous equations here. I can solve them by making 3a plus 3g sine 20 equal to that. So then I take this term over to there, this term over to here, and I find that A is 1.93 meters per second. So that's part B completed. Let's have a look at part C now. How have we used the assumptions that the pulley is smooth and the string is inextensible? Well, the pulley is smooth. That enables us to say that the tensions on each side of the pulley are equal. So these two tensions are the same as those two tensions. If the pulley was rough, then these tensions would be different from these tensions here. And the string is inextensible. That means that the acceleration of particle B is equal to the acceleration of particle A. So there we are.